The ocean covers most of Earth. More than 70% of the planet's surface is blanketed by the vastness of salt water. This immense body is not only a feature of beauty, it is a system that regulates weather, provides food, and shelters countless living creatures. When one imagines the globe, the continents appear as scattered shapes, while the ocean stretches unbroken in wide expanses. The Pacific alone is larger than all land combined, reminding us that water is the dominant element of Earth. Within its surface lies mystery, calm, and unimaginable depth. Beneath the waves are canyons, mountains, and plains that mirror the landscapes above, but on a much larger scale. The sheer scope of the ocean allows for endless wonder, and its surface barely hints at the secrets hidden within its darker reaches.
The deepest point is Challenger Deep. Located within the Mariana Trench in the western Pacific Ocean, Challenger Deep plunges nearly 11 kilometers beneath sea level. If Mount Everest were placed upside down inside this trench, its peak would still not break the water's surface. Few people have visited this place, and the extreme pressure makes human exploration a daunting challenge. Robotic submersibles and specialized vessels have descended into this watery abyss, capturing images of a landscape that looks otherworldly. At such depths, strange life forms exist, adapted to pressure that would crush metal. The name Challenger Deep honors the 19th century HMS Challenger expedition, which first charted this area and revealed the vast mysteries beneath.
Sunlight barely reaches the deep sea. Light from the sun penetrates only a short distance into the water, fading almost completely by 200 meters. Beyond that point, darkness dominates. The majority of the ocean wrapped in eternal night, with no hint of sky or daylight. Creatures living here must find ways to survive without photosynthesis or visual cues. Many rely on touch, sound, or chemical signals to navigate. Some have developed glowing organs that create their own light, a phenomenon known as bioluminescence. To imagine this endless night is to imagine drifting in silence, surrounded by water that stretches in all directions, a calm yet haunting realm, far removed from the brightness of the surface.
Pressure increases with ocean depth. For every 10 meters one descends into the ocean, the pressure rises by roughly 1 additional atmosphere. At the deepest points, this pressure is over 1,000 times greater than what we feel at the surface. Such force could crush a human body instantly. Yet deep-sea creatures thrive here, with bodies perfectly adapted to withstand the weight. Their bones may be minimal, their structures flexible, and their cells filled with fluids that balance the external pressure. Submarines built for exploration require careful engineering to prevent collapse. This invisible yet powerful force creates an environment that is both dangerous and fascinating, a quiet reminder of the ocean's strength.
Deep currents shape Earth's climate. Beneath the surface, water flows in slow, massive rivers known as thermohaline currents. These currents are driven by differences in temperature and salinity, carrying heat and nutrients across the globe. Sometimes called the ocean conveyor belt, this system connects all major basins, linking the Atlantic, Pacific, Indian, and Southern Oceans into a single moving circulation. The movement helps regulate climate, moderates seasons, and distributes life-supporting oxygen. Without these deep flows, many coastal regions would be barren, and the planet's climate would be far more extreme. The gentle but constant rhythm of these currents is like the heartbeat of Earth, unseen yet vital.
Hydrothermal vents support hidden life. On the ocean floor, where tectonic plates shift and spread, hot springs burst from cracks, releasing mineral-rich water. These hydrothermal vents are like underwater chimneys, spewing superheated liquid into the icy depths. Despite the harshness, entire communities of organisms thrive here, drawing energy not from sunlight, but from chemical reactions. Tube worms, clams, and shrimp gather in vast colonies, supported by bacteria that process the vent's minerals. This discovery challenged long-held beliefs about life, showing that ecosystems can exist without the sun. The vents remind us that Earth is filled with hidden possibilities, where life adapts in remarkable ways to survive. Bioluminescence lights the ocean darkness. In the endless night of the deep ocean, many creatures produce their own light. This bioluminescence can appear as soft blue glows, flashing patterns, or drifting sparks that resemble stars. Fish use it to lure prey, squid to confuse predators, and plankton to signal each other. The chemical process is efficient, releasing light without heat. For those who have seen recordings from submersibles, the experience is mesmerizing, as if the ocean floor holds a galaxy of tiny constellations. This natural wonder turns darkness into a stage of glowing displays where survival and beauty are illuminated by gentle light. The ocean floor is still unmapped. Despite modern technology, large portions of the ocean remain unknown. Scientists have mapped the surface of Mars with greater precision than Earth's seabed. The depth, darkness, and sheer size of the oceans make exploration slow and incomplete. Only a fraction of the floor has been charted in detail, and vast regions are still blank spaces on our maps. Within these unmapped areas may lie mountains taller than Everest, trenches deeper than we know, and ecosystems beyond imagination. The mystery of what lies below continues to inspire exploration, reminding us of how little we truly understand about our own planet. Ancient shipwrecks rest in the deep. Beneath the waves, countless vessels from centuries past now lie silent on the sea floor. Preserved by cold, dark water, Some are remarkably intact, their wooden frames still recognizable. These wrecks are time capsules, holding the stories of sailors, merchants, and explorers who once crossed oceans. From ancient trading ships to modern vessels lost in storms, each wreck offers a glimpse into human history. Archaeologists study these sites with care, learning about past cultures and seafaring traditions. In the stillness of the deep, these silent remains rest undisturbed, watched only by curious fish and drifting currents.
Whale falls create unique ecosystems. When a great whale dies, its body eventually sinks to the bottom of the sea. This event, known as a whale fall, provides a sudden feast for countless organisms. Scavengers arrive first, stripping flesh from bone, followed by smaller creatures that feed on leftovers. In time, bacteria colonize the skeleton itself, releasing nutrients that sustain entire communities for decades. These whale falls create islands of life in an otherwise barren landscape, demonstrating how death in the ocean can bring renewed vitality. Each one becomes a temporary oasis, supporting unique species that exist nowhere else on Earth.
The midnight zone is vast. The ocean contains a layer called the bathypelagic or midnight zone, stretching from 1,000 meters down to 4,000 meters. This region is cloaked in absolute darkness, where sunlight never reaches. Here, temperatures hover near freezing, and pressure is immense. Yet life thrives. Strange fish with enormous jaws, delicate jellyfish, and glowing squid move silently through the waters. Most creatures are slow-moving, conserving energy in an environment with little food. The midnight zone represents the largest habitat on Earth by volume, a place of silence and mystery that remains almost entirely hidden from human eyes.
Gigantic squid roam the deep. Legends of sea monsters may have been inspired by real creatures that inhabit the deep-sea depths. The giant squid and colossal squid are elusive animals with eyes as large as dinner plates and tentacles lined with hooks or suckers. They can grow longer than school buses, drifting silently in the darkness. For centuries, they were known only through myths and washed-up remains, but cameras have finally captured them alive. These rare glimpses show beings that seem almost alien, yet they are a natural part of the deep-sea ecosystem. Their presence adds to the awe and wonder of unexplored waters. Cold seeps release hidden gases. On the ocean floor, areas known as cold seeps slowly leak gases like methane and hydrogen sulfide into the water. Unlike hydrothermal vents, the fluids here are not heated, yet they still support diverse ecosystems. Microbes thrive on the chemicals, creating a base food for clams, mussels, and tube worms. Some cold seeps are vast fields that look like underwater meadows, while others form strange mud volcanoes. These hidden landscapes remind us that life is not limited to sunlight or warmth. Even in cold, dark places, energy seeps from the earth, nourishing organisms in remarkable ways. Sound travels far underwater. In the deep ocean, sound moves more efficiently than in air, traveling great distances with little loss. Whales use this property to communicate across hundreds of kilometers, sending songs and calls that carry through the water. Submarines and scientists also rely on sonar, which bounces sound waves off objects to reveal their location. Some mysterious sounds have been recorded that remain unexplained, such as the famous bloop in the 1990s, a loud, low-frequency noise detected in the Pacific. Whether natural or not, these distant calls remind us that the ocean is alive with voices that drift unseen through its depths.
The abyssal plain is enormous. Vast stretches of the ocean floor are covered by flat, featureless plains that extend for thousands of kilometers. Known as abyssal plains, they lie between 3,000 and 6,000 meters deep. These regions are coated in fine sediments that slowly settle from above, burying features beneath layers of soft mud. Though they may seem empty, life is present, with starfish, cucumbers, and worms crawling across the sediment. The sheer scale of these plains makes them one of the largest environments on Earth. They form a quiet and expansive realm where time seems to move slowly and steadily.
Brine pools look like underwater lakes. In some parts of the ocean, dense salty water collects in depressions, creating pools that sit beneath the surrounding seawater. These brine pools appear as shimmering lakes with distinct shorelines, a surreal sight in the deep. The water inside is far saltier and often toxic, preventing most life from entering. Yet, around the edges, unique organisms gather, forming communities adapted to this harsh boundary. The pools resemble alien landscapes, with waves and ripples beneath the sea. They are a reminder of how strange and varied the ocean can be, holding wonders that blur the line between the familiar and the unknown.
Deep-sea fish have strange adaptations. The creatures of the deep ocean display features that seem bizarre compared to surface animals. Some have enormous jaws and sharp teeth to capture scarce prey, while others are nearly transparent to avoid detection. Many have bioluminescent lures, glowing spots, or lantern-like organs to attract food or mates. Their bodies are often soft and flexible, able to withstand crushing pressure without breaking. Some species have never been seen alive, known only from remains pulled up in nets. Each adaptation tells the story of survival in an environment where resources are rare and darkness rules. Oxygen levels vary in the deep. The ocean is not uniform in its oxygen content. Between certain depths, there exist oxygen minimum zones where levels drop very low. These layers create challenges for animals that pass through, and only specialized species can survive within them. Above and below, oxygen is more plentiful, carried by currents and surface mixing. Such layers influence where fish can live, where plankton drift, and how nutrients are recycled. These invisible boundaries shape the ecosystems of the deep, guiding the movement of creatures through the water. Though unseen, they are essential to the balance of life in the ocean.
Deep sea corals build hidden reefs. Not all coral lives in warm, shallow waters. In the cold and dark of the deep ocean, corals form vast reefs that rival tropical systems in size and complexity. These corals do not rely on sunlight, but feed by capturing tiny drifting organisms. Some reefs are thousands of years old, rising like hidden mountains from the seafloor. They provide shelter for fish, crustaceans, and countless small species. Scientists continue to discover new reefs in unexpected places, revealing that the ocean holds more biodiversity than once imagined. These deep coral gardens are fragile treasures, largely unseen yet vital to marine life.
Ice brinicles form deadly fingers. In polar seas, when sea ice forms, salty brine is released downward into the water. This creates streams of dense, freezing liquid that sink and solidify around them. Known as brinicles, these icy fingers reach toward the seafloor, freezing everything they touch. Starfish and sea urchins caught in their path are trapped in ice, unable to escape. The sight of a brinicle forming is hauntingly beautiful, like a frozen stalactite descending in slow motion. These rare events showed the surprising and sometimes harsh processes that shape life in the deep. Deep-sea vents form mineral chimneys. At the edges of tectonic plates, hot fluids rise through cracks in the ocean floor and cool rapidly when they meet seawater. Minerals in these fluids harden into tall, chimney-like structures that can grow many meters high. These vents are sometimes called black smokers or white smokers, depending on the minerals they release. Around them, entire ecosystems flourish, drawing energy from chemical processes rather than sunlight. Bacteria form the base of the food chain, supporting tube worms, crabs, and fish. These chimneys demonstrate how Earth continuously reshapes itself, creating habitats in the least expected places.
Marine snow drifts constantly downward. In the dark zones of the ocean, a steady rain of organic particles falls from the surface. This mixture of plankton remains, fecal matter, and tiny fragments is called marine snow. It drifts slowly through the water column, glowing faintly when disturbed. For many deep-sea creatures, this gentle snowfall is the primary source of food, sustaining life far from the sunlit surface. Some particles take weeks to reach the seafloor, feeding organisms along the way. Marine snow links the surface world with the deep, a quiet connection that nourishes even the most remote places. Certain fish produce red light. Most bioluminescence in the deep sea glows blue or green, colors that travel farthest in water.
Yet a few species of fish have evolved the rare ability to emit red light. Because few creatures can detect red wavelengths, this light acts like a secret signal, visible only to those who create or sense it. Predators may use it to illuminate prey without being seen, while some use it for communication. The presence of red light in an environment dominated by darkness is a reminder of how evolution invents unique solutions to the challenges of the deep.
Some trenches rival mountain ranges. Oceanic trenches are among the most dramatic features on Earth, cutting deep into the crust and stretching for thousands of kilometers. The Mariana, Tonga, and Philippine trenches are vast enough to rival the great mountain ranges on land. Their walls rise steeply, creating hidden landscapes that few have ever seen. At the bottom of these trenches, pressure is immense and temperatures are near freezing. Yet life persists, with amphipods, snailfish, and microbial mats adapting to these extreme conditions. These trenches are silent reminders that Earth's most striking geography often lies beneath the waves. Deep-sea creatures grow to giant size. In the darkness of the abyss, some animals reach sizes far larger than their shallow-water relatives. This phenomenon, known as deep-sea gigantism, is seen in giant isopods, enormous amphipods, and colossal squid. The reasons for this growth are debated, but cold temperatures, high pressure, and slow metabolisms may play roles. These giants move gracefully through the depths, their unusual forms inspiring curiosity and sometimes fear in those who first encounter them. They are part of the ocean's quiet mystery, evidence that life adapts in ways we do not fully understand.
Submarine canyons cut through the seafloor. Along many continental margins, vast underwater canyons slice deep into the seabed. These submarine canyons can be larger than the Grand Canyon. Carved by ancient rivers and currents, they act as highways for sediments and nutrients, channeling material from shallow waters to the abyssal plains. Within them, diverse communities flourish, sheltered by steep walls and varying currents. Fish, corals, and invertebrates gather in these hidden valleys, making them hotspots of biodiversity. These canyons are reminders that the ocean floor is far from flat, filled instead with dramatic landscapes.
Life thrives in extreme cold. Temperatures in the deep ocean hover near freezing. Yet countless organisms survive and flourish there. Their bodies contain special proteins and antifreeze-like compounds that prevent ice crystals from forming inside their cells. Some fish, such as Antarctic icefish, have blood that remains liquid in sub-zero conditions. Despite the chill, these creatures move gracefully, conserving energy and adapting to their environment. The ability of life to endure such extremes shows the resilience of nature. In the stillness of the cold, life continues quietly, demonstrating remarkable persistence. The deep ocean stores carbon.
The ocean acts as one of the largest reservoirs of carbon on Earth. Surface waters absorb carbon dioxide from the air, and much of it eventually sinks into the deep through particles, currents, and biological processes. This slow movement stores carbon for centuries or even millennia, helping regulate Earth's climate. Deep-sea organisms play a role by consuming and recycling organic matter, locking carbon into their bodies and sediments. This hidden cycle demonstrates how the ocean silently balances the atmosphere, influencing life on land as well as underwater. Undersea volcanoes create new landscapes. Beneath the surface, volcanic activity is constant, forming mountains and islands that rise from the sea floor. These undersea volcanoes erupt lava that cools quickly, building structures called pillow lavas. Some volcanoes form chains that stretch for thousands of kilometers, like the Mid-Atlantic Ridge. Life often gathers around volcanic sites, feeding on minerals released during eruptions. Entire ecosystems may spring up where none existed before. These fiery processes shape the ocean floor, creating new habitats that slowly become part of the planet's geology. Many species remain undiscovered. Scientists estimate that only a fraction of deep-sea species have been identified. With every new expedition, researchers find fish, invertebrates, and microorganisms that were previously unknown. Some have unusual shapes, glowing organs, or delicate bodies unlike anything seen before. The vastness of the deep means countless forms of life are still hidden, waiting to be found. Each discovery expands our understanding of evolution and survival. The ocean remains a frontier of exploration, holding secrets that may take centuries to uncover. Sharks patrol the deep waters. While many sharks live near coasts, some species roam the depths in silence. The goblin shark, with its long snout and extendable jaws, drifts in twilight zones. The frilled shark, often called a living fossil, coils through the dark like an eel. Greenland sharks move slowly in icy waters, living for centuries and becoming some of the longest-lived vertebrates on Earth. These deep dwellers are rarely seen by humans, yet they play important roles in balancing marine food webs. Their presence reminds us that ancient predators still rule hidden corners of the ocean. Deep-sea jellyfish display beauty. Jellyfish found in the deep ocean often look like delicate lanterns drifting through darkness. Some are transparent bells with glowing filaments, while others pulse with rhythmic lights that ripple across their bodies. Many species are fragile and difficult to study, collapsing when brought to the surface. Despite their soft nature, they thrive in high-pressure environments, drifting gracefully as currents carry them. Their otherworldly forms highlight the diversity of life in the deep. Each encounter with these jellyfish is a glimpse of fragile beauty, shining faintly in the silence of the abyss. Methane hydrates lie beneath sediments.
In many deep ocean regions, methane gas is trapped within icy structures called methane hydrates. These crystalline forms look like packed snow but can burn when brought to the surface. Hydrates store immense amounts of carbon, locked safely under cold, high-pressure conditions. Some scientists view them as potential energy resources, while others study their role in climate. In the deep, they sometimes shape ecosystems, providing energy for unique microbes. These frozen reservoirs are hidden treasures, mysterious and powerful, quietly resting beneath layers of sediment.
Sea cucumbers clean the sea floor. Among the most common inhabitants of the deep ocean are sea cucumbers, soft-bodied creatures that slowly crawl across sediments. They consume organic matter, digesting it and releasing clean sand behind them. In this way, they recycle nutrients and help maintain balance in abyssal plains. Their bodies come in many shapes, some resembling drifting balloons, others resembling crawling sausages. Though not often admired, their work sustains countless ecosystems. By quietly processing the ocean floor, sea cucumbers show how even the simplest creatures perform vital roles.
Sea cucumbers clean the seafloor. Among the most common inhabitants of the deep ocean are sea cucumbers, soft-bodied creatures that slowly crawl across sediments. They consume organic matter, digesting it and releasing clean sand behind them. In this way, they recycle nutrients and help maintain balance in abyssal plains. Their bodies come in many shapes, some resembling drifting balloons, others resembling crawling sausages. Though not often admired, their work sustains countless ecosystems. By quietly processing the ocean floor, sea cucumbers show how even the simplest creatures perform vital roles.
Underwater ridges span entire oceans. The longest mountain ranges on Earth are not found on land, but beneath the seas. Mid-ocean ridges stretch across thousands of kilometers, forming continuous chains that circle the globe. These ridges mark where tectonic plates separate and magma rises to form new crust. At their peaks, hydrothermal vents and volcanic eruptions are common, creating dynamic environments filled with life. Submarines exploring these ridges often reveal landscapes of peaks, valleys, and cliffs. These hidden mountains are vast reminders of the restless energy that shapes Earth.
Glass sponges build deep reefs. In the cold, dark waters of the deep sea, sponges with skeletons of silica create fragile reef structures. Known as glass sponges, their delicate forms resemble lace or fine crystal. Colonies of these sponges grow together, forming reefs that provide shelter for fish and invertebrates. Some reefs are thousands of years old, growing slowly in silence. Their skeletal remains create layers that stand as monuments of persistence. These reefs are among the ocean's oldest living communities, silent architects of beauty in the abyss.
Currents stir nutrients upward, While deep currents flow steadily around the globe, they occasionally rise toward the surface in a process known as upwelling. This upward movement brings nutrients from the sea floor into sunlit waters, feeding plankton blooms that support entire food chains. Coastal regions near upwelling zones are often rich in fish, sustaining both marine life and human communities. The connection between deep and surface waters is vital, linking hidden depths with life above. Without this cycle, oceans would be far less productive. Upwelling is the deep ocean's quiet gift to the world. Some fish live upside down. In the depths, fish adopt surprising behaviors to survive. One unusual species, the upside-down fish, rests with its belly facing upward against cave ceilings or under ledges. This orientation helps it feed on particles drifting above while staying hidden from predators. Other fish swim at angles or hover in place, conserving energy in still waters. Such oddities remind us that life in the deep is flexible and inventive. Every behavior is shaped by the challenges of darkness, scarcity, and pressure, resulting in remarkable survival strategies.
Deep ocean trenches trap sediments. Over time, sediments from rivers, volcanic eruptions, and surface organisms settle into trenches. These deep basins act as storage places for layers of mud, sand, and organic remains that may build up for millions of years. Within these layers are records of past climates, volcanic events, and even ancient life. Cores taken from trenches reveal histories that stretch back beyond human memory. The trenches act as libraries of Earth's past, holding information in silence until it is studied. In this way, they preserve stories of the planet itself.
Many animals migrate daily. One of the largest migrations on Earth happens every day within the ocean. At dusk, billions of small fish, squid, and plankton rise from deep waters to the surface to feed. Before dawn, they descend again to avoid predators. This movement, called diel vertical migration, involves more creatures than any land migration. It links the surface world with the deep, transferring energy between layers of the ocean. The daily journey is unseen by most people, yet it represents one of the greatest rhythms of life on Earth. Deep oceans hide ancient fossils. Layers of sediment on the ocean floor preserve the remains of organisms that lived millions of years ago. Tiny shells of plankton, fish bones, and even larger skeletons become buried and slowly turn into fossils. These deposits allow scientists to trace changes in climate and evolution across vast spans of time. In some places, deep-sea drilling has brought up samples filled with microscopic fossils that tell stories of shifting oceans and ancient atmospheres. Each fossil is a whisper from the past, resting quietly in the dark until uncovered. Some fish
have transparent heads. One of the strangest discoveries of the deep is the barrel eye fish. This small creature has a clear dome-shaped head through which its tubular eyes can be seen. The eyes rotate upward to watch for prey silhouetted against faint light, or forward when the fish needs to feed. Its unusual anatomy helps it survive in the dim twilight zone. Rarely seen alive, the barrel eye reminds us that the deep ocean is home to adaptations that seem beyond imagination, shaped by pressures and darkness into forms that appear unreal.
Deep ocean currents move slowly. Unlike surface waves, deep ocean currents can take centuries to complete a single journey around the globe. These currents flow in steady, deliberate paths, connecting polar regions with the equator and cycling water between layers. Their movement helps regulate global climate by carrying heat and distributing dissolved gases. Though invisible to the human eye, these currents are among the most powerful systems on Earth. Their quiet circulation is a hidden rhythm that shapes weather, seasons, and the health of marine ecosystems. Strange worms thrive at great depths. In the deepest trenches, worms have been found that live in mud where pressures are extreme. Some are long and thread-like, while others build tiny tubes from surrounding sediments. They feed on organic particles that drift down, recycling nutrients in the dark. Certain species have only been observed once or twice, vanishing into the depths before they could be studied further. These worms may seem simple, yet they embody the resilience of life, thriving quietly in places few others can endure. Deep-sea life is often slow. With scarce food and freezing temperatures, many creatures of the abyss move slowly, conserving energy. Fish drift rather than chase prey. Invertebrates wait for particles to settle, and predators strike rarely but decisively. Growth is also slow, with some species living for centuries. This unhurried pace gives the deep ocean a timeless quality, where survival depends on patience and efficiency. Observing such life reveals an alternate rhythm of existence, one shaped by silence and endurance rather than speed. Rare minerals form on the seabed. In certain areas, metallic nodules grow slowly on the ocean floor, layer by layer, around fragments of shells or stones. These nodules contain manganese, nickel, copper, and other valuable elements. Some are the size of pebbles, while others grow as large as potatoes, taking millions of years to form. They lie scattered across abyssal plains like quiet fields of stone. While industries consider mining them, these nodules also support fragile ecosystems. They are both treasures of geology and sanctuaries of life in the deep. Deep oceans create strange sounds. Recordings made underwater have captured eerie noises that echo across great distances. Some are caused by shifting icebergs, volcanic activity, or the calls of whales, while others remain unexplained. The bloop, Julia, and upsweep are names given to mysterious sounds that puzzle researchers. These noises travel far in the dense medium of water, sometimes recorded thousands of kilometers away.
Whether natural or from unknown sources, they remind us that the deep is not silent, but filled with voices that remain hidden in darkness.
Starfish live in extreme depths. Starfish are not limited to shallow tide pools. They also inhabit abyssal plains and trenches. In the deep, some species grow larger and develop unique shapes, with arms that appear spiny or feathered. They move slowly across sediments, feeding on small organisms and detritus. Despite the cold and pressure, they continue the same quiet existence as their shallow cousins. Their presence in such depths shows the adaptability of familiar creatures, surviving unchanged in spirit while dwelling in the most remote environments on Earth.
Some fish create living lures. Anglerfish are perhaps the most famous of deep-sea predators, with glowing lures that dangle in front of their mouths. These lights are produced by symbiotic bacteria housed within fleshy growths. Small fish and invertebrates are drawn to the glow only to be swallowed whole by the waiting predator. The sight of an anglerfish with its light floating in the dark is both eerie and fascinating. Its adaptation demonstrates the creative strategies of life in the absence of sunlight.
Deep oceans remain mostly unexplored. Despite advances in technology, less than a quarter of the ocean floor has been mapped with high detail, and only a fraction has been physically explored. The majority of Earth's largest habitat remains unseen by human eyes. Each expedition reveals something new, whether a species, a landscape, or a chemical process never before imagined. The vast, unexplored areas of the ocean remind us that mystery still exists in abundance on our planet. The deep remains Earth's final frontier, silent and waiting.